Hello everyone, welcome. So for the past 4 to 5 videos, we are seeing previous year solutions of UPSC Mathematics Optional paper on linear algebra. So we have already completed 2020 to 2024 solutions, right? So if you haven't watched all those previous videos, so kindly I recommend you to watch that video and come back to this video, right? Because I've explained many concepts in that video which will be useful when solving problem in this video, right? Okay, so again 2019 has 5 questions for 70 marks. So we will solve all those 5 questions. So very simple. Every time I'm saying that if you know the concepts really well, conceptually in linear algebra, you can easily get 60 to 70 marks, whatever they are asking in linear algebra. Yes. So we will start our first problem. Let T is a map from R2 to R2 defined by T of, okay, they haven't given map, they haven't given the map explicitly. So we will find the map such that they have given that T of 2 comma 1 maps to 5 comma 7 and T of 1 comma 2 maps to 3 comma 3. So first what we will do is we will find the corresponding linear map associated with these two given information, right? Okay, so what we'll do is first we will find a linear map T of x comma y. After finding that linear map T, for that linear map T, you find the matrix of T with respect to the standard basis, and then for that matrix you find the rank of T. Very simple question. So first what you have given is T is a map from R2 to R2, right? They have given that we don't know T of x comma y, but we know that T of 2 comma 1, T of 2 comma 1 maps to 5 comma 7, and T of 1 comma 2 maps to 3 comma 3, right? Now what we'll do is we will find what is this T of x comma y, right? First we will find what is T of x comma y. Now we already solved these similar kinds of problem, right, in the previous lectures. That is, now you take an element x comma y in R2, then this x comma y can be written as the linear combination of basis vector. So here 2 comma 1 and 1 comma 2 both are linearly independent set. That means this A can be written as linear combination of comma 1 plus b times 1 comma 2. Already I've said what I've said already. You have to write, you have to find the value of AB in terms of xy. You already explained, right? You have to find the value of AB in terms of xy. So we will find AB in terms of xy. So we have 2A plus B is equal to x, and then we have A plus 2B is equal to y. You have to solve for AB, that's it, right? You have to solve for AB. So what we'll do is solve this as 1, solve this as 2. Now solve for A and B in terms of x and y, right? You have to solve for AB in terms of x and y. So just solve this equation. So we have 2A plus B is equal to x. You multiply this by 2. So we have 2A plus 4B is equal to 2y. Subtract this. That means we will have minus 3B is equal to x minus 2y. That means B is equal to minus 1 by 3 of x minus 2y. Yes or no? I'm just multiplying 2 throughout. So 2a, 4b, 2y. You subtract this. So b minus 4b, x minus 2y. I have found b in terms of xy. Now, now a is equal to what? A is equal to y minus 2 times b. So y minus 2 times b. So it will be plus 2 by 3 of x minus 2y. So we have 3y plus 2x minus 4y whole divided by 3. So we have this to be 2x minus y by 3. So we have found AB in terms of xy. That is our first step. Now, uh, what is x comma y? X comma y can be written as A times 2 comma 1 plus B times 1 comma 2. Now you take t on both sides. So t of x comma y, this A is linear, I can take outside. Scalar, you can take outside. So A times t of 2 comma 1 plus b times t of 1 comma 2. Now what is A? A value is given by 2x minus y by 3. What is t of 2 comma 1? T of 2 comma 1 maps to 5 comma 7 plus b. What is b? Minus 1 by 3 x minus 2y. What is t of 1 comma 2? It maps to 3 comma 3. Right? Now just have to simplify the first components. So we will have 5 times 2x minus y by 3 minus 3 times x minus 2y whole divided by 3. See, I'm just multiplying and adding, that's it. So 7 times 2x minus y by 3 minus 3 by 3 x minus 2y. Right? Okay. So this is equal to, so 5 2s are 10x, 10x minus 3x, 7x, right? 7x minus 5y minus 5y plus 6y minus 5y plus 6y. So it is plus y whole divided by 3, comma 7 2s are, you don't cancel this 3 3. It will be easy for us to calculate, right? Or else want to take LCM. So 14x minus 3x, 11x by 3 minus 7y plus 6y minus 7y plus 6y minus y whole divided by 3. So this is a linear, this is our required linear transformation. So t of x comma y is given by 7x plus y by 3, 11x minus y by 3, right? This is our linear map which is given by t of x comma y. This is our linear map. You can check it out. You substitute 2 comma 1. You substitute x is 2, y is 1. X is 2, y is 1. 7 2s are 14, 14 plus 1 15, 15 by 3 5. Yes. X is equal to 2, y is equal to 1. X is equal to 2 22, 22 minus 1 21, 21 by 3 7. Yes, good. So our x comma t of x comma y is correct. So this is our required linear map that takes 2 comma 1 to 5 comma 7 and 1 comma 2 to 3 comma 3. This is a general linear map. This is how to find the linear map if you know some output vectors. Now, if A is the matrix of T corresponding to T with respect to the standard basis. So, what is T of x comma y? What is T of x comma y? It is given by 7x plus y by 3, 7x plus y by 3, comma 11x minus y by 3, 11x minus y by 3. So, we will find the matrix of T with respect to the standard basis. So, T of 1 comma 0. So, what is T of 1 comma 0? It is 7 plus 0 by 3, 11 minus 0 by 3. And what is T of 0 comma 1? So, it is 1 by 3 minus 1 by 3. So, what is the matrix of T with respect to the standard basis? So, it is 7 by 3, 11 by 3, 1 by 3 minus 1 by 3. Right? You can see determinant is not equal to 0 for this transformation, right? What is determinant of T? Minus 7 by 9, minus 7 by 9, minus 7 by 9, minus 11 by 9. So this is not equal to 0, right? That means rank will be equal to what? Rank will be equal to 2, right? This is minus 7 by 9 minus 11 by 9. So determinant is not equal to 0. That means rank of T will be equal to 2. Unless you just reduce to row echelon form, you will not have 0 rows after reducing to row echelon form, right? So therefore, A is the matrix of T with respect to the standard basis. So matrix of A is given by this. We need to find the rank of A. So rank of A is 2. Very simple problem. How many marks? 10 marks. Let T is a map from R2 to R2 be a linear map such that T of 2 comma 1 takes 5 comma 7 and T of 1 comma 2 takes 3 comma 3. So we have found a linear map which is 7x plus y by 3, 11x minus y by 3. This is a required linear map. Now, for this linear map, you find the matrix with respect to the standard basis. Call that as a matrix A. For that matrix A, you find the rank. So the rank is equal to 2. Okay, so we'll move on to second problem. Again, very simple problem. Like just 11th standard, 12th standard level problems. 10 marks. If A is equal to 1, 2, 1, 1 minus 4, 1, 3, 0 minus 3, and B is equal to 2, 1, 1, 1 minus 1, 0, 2, 1 minus 1, show that AB is equal to 6 times of I3. Using this, solve this equations. Okay. So we need to find the product AB. So AB, so 1, 2, 1, 1 minus 4, 1, 3, 0 minus 3, product 2, 1, 1, 1 minus 1, 0, 2, 1 minus 1, right? Now just multiply this. 1 2s are 2 plus 2 plus 2. Here you will have 1 minus 2 plus 1, 1 plus 0 minus 1, 2 minus 4 plus 2, 1 plus 4 plus 1, 1 plus 0 minus 1, 6 plus 0 minus 6, 3 plus 0 minus 3, 3 plus 0 plus 3, right? So which is equal to 600,060,006, which is equal to what? 6 times identity matrix, right? You take 6 outside, this is equal to 6 times of ID matrix. So show that AB is equal to 6 times I3. AB is equal to 6 times I3. Now we need to solve this equation. Now we need to solve 2x plus y plus z is equal to 5. X minus y is equal to 0. 2x plus y minus z is equal to 1. See, actually, this coefficient matrix is nothing but your A matrix, right? Can you infer what is determinant of this matrix? It will be non-zero, right? Just find determinant for this matrix. So 1 times 12 minus 2 times minus 3 minus 3 minus 6. So minus 12 and 1 times 0. Yes, it will be non-zero, right? Okay, determinant of A is non-zero. Now we will solve this by matrix elimination method. I can write I can write this as 2 1 1 1 minus 1 0 2 1 minus 1 times x y z equal to 5 0 and 1, right? 5 0 and 1. So since this matrix determinant this matrix is A, and for this determinant is not equal to 0, that means inverse exists. So that means I can write this x comma y comma z as let us call this matrix as A, right? Because already you have given this matrix as A. So I can write this as A inverse. I'm taking this to that side. It will be A inverse because inverse exists for this because determinant not equal to 0. A inverse times 5 comma 0 comma 1, right? So x comma y comma z is A inverse this times this. If I take that side, it will be A inverse times 5 comma 0 comma 1. Now we have to find inverse for A. It will take some time. A inverse is what? 1 by determinant of A into unsigned of A. But you don't need to do because we know that AB is equal to 6 times I. And I write this as A into B by 6 is equal to I, right? Now what we'll do is we will pre-multiply by A inverse. If we pre-multiply by A inverse into B by 6 is equal to I times A inverse. So A into A inverse is ID matrix because A inverse existed, right? Determinant of A not equal to 0. That means A inverse existed. That means what? A into A inverse is equal to ID matrix by definition. I can write this as ID matrix I. So that means A inverse is nothing but B by 6. You don't need to find inverse. If you multiply B with 1 by 6, that will be your inverse. So that means this will be equal to 1 by 6 times of B 5 0 1. So 1 by 6 times of because we need to solve this using this result. That's why 3 times, so 2 comma 1 comma 1, 1 comma minus 1 comma 0, 2 comma 1 comma minus 1, 5 comma 0 comma 1. So 1 by 6 times it will be what? 2 5s are 10, 10 plus 0 plus 1. So it will be 11. And we have 5 plus 0 plus 5 plus 0 plus 0, 10 plus 0 minus 1. Yes or no? So that's it. This is your solution. Okay, okay. I think I made mistake. See, this matrix is B matrix, not A matrix. Okay, sorry, sorry. I thought that's A matrix. Matrix is B matrix, right? Sorry. Same thing only. Same thing. Okay. This matrix is B matrix, right? 2 1 1 1 minus 1 0. This matrix is B matrix. And for B matrix, determinant of B is not equal to 0, right? Just my determinant for this matrix. So 2 times 1, so you will have 2 minus 1 times, yes, it will be non-zero. So that means B inverse exists, right? So x comma y comma z can be written as B inverse times 5 comma 0 comma 1. Now what is B inverse? So we know that AB is equal to 6 times I. So, so I can write this as A by 6 B is equal to 6. Now you post multiply by B inverse. Now you post multiply by B inverse. You post multiply by B inverse. So B inverse existed. That means B into B inverse is ID matrix. So that means B inverse is nothing but A by 6. Right? So I can write this B inverse as 1 by 6 are A times 5 comma 0 comma 1. So 1 by 6 are, what is A? A is 1 to 1, 1 to 1, 1 minus 4, 1, P0 minus 3 times 5 comma 0 comma 1. So 1 by 6 times, so 5 plus 0 plus 1, 6, 5 plus 0 plus 1, 6 again, 3 plus 3 pies are 15, 15 minus 3, so 12. So the solution is 1 comma 1 comma 2. Right, sorry. I thought it is A matrix. I was, just like I saw 2, I found. Okay, sorry. Thanks. Sorry for wasting your time. This is B matrix, right? So the x comma y comma z is B inverse into 5 comma 0 comma 1. So B inverse is just note this down, right? B inverse is A by 6. B inverse is A by 6. So in place of B inverse, you just substitute as A by 6, right? Okay. So solution is 1 comma 1 comma 2. Okay. So we'll move on to the next thing. This carries 15 marks. Okay. Let A and B be two orthogonal matrix of same order. Let A and B be two orthogonal matrix. So A and B are two orthogonal matrix. Two orthogonal matrix of same order, right? So that is A into A transpose is equal to I, and B into B transpose is also equal to I. If A into A transpose is equal to I, okay, let us consider this. Now, if I take determinant on both sides, determinant of A into A transpose is equal to I. So, determinant of AB is determinant of A into determinant of B. equal to determinant of ID matrix is 1. So determinant of A transpose is same as determinant of A. Determinant of A is 1. That means determinant of A square is 1. Right? If A is orthogonal matrix, determinant of A square is 1. And similarly, determinant of B into B transpose is equal to determinant of I. This is determinant of B transpose is 1. Determinant of B is equal to 1 because determinant of B is same as determinant of B transpose. So determinant of B square is also 1 if B is orthogonal. Okay. A and B are orthogonal matrix. From this, we have collected this much of information. A into A transpose is I, and determinant of A square is 1. B into B transpose is I, and determinant of B square is also 1. And determinant of A plus determinant of B, determinant of A plus determinant of B is equal to 0. We are given determinant of A plus determinant of B is equal to 0. Now what we need to show is now what we need to show we need to show A plus B is a singular matrix. A plus B is a we need to show A plus B is a singular matrix. That is, we need to show determinant of A plus B is equal to 0. So we have this much of information, right? This is call this as 1, call this as 2, call this as 3. So with the help of 1, 2 and 3, we will show that A plus B is equal to 0, right? Okay. Now what I'll do is now I'll find determinant of A plus B whole square. So if I expand this, you will have determinant of A square, determinant of B square plus 2 times determinant of A, determinant of B, right? 2 times determinant of A into determinant of B. Okay. Now, they have said that determinant of A plus determinant of B is 0. That means, can I write determinant of B is equal to minus determinant of A? So what we'll do is determinant of A whole square. Can I write determinant of B square? Determinant of B square is determinant of A square, right? Determinant of A square, or else I can also prove like we know determinant of we'll do like this. We know determinant of A square is 1, right? So we'll use it directly. So determinant of A square is 1. Determinant of B square is also 1. So we'll have 1 plus 1, right? Plus 2 times determinant of A. Can I write determinant of B as minus determinant of A? Determinant of B as minus determinant of A. So we have 2 minus 2 times determinant of A whole square. So 2 minus this 1 again. So that means determinant of A plus B whole square is 0. That means what? Determinant of A plus B is also 0. Determinant of A plus B is 0 means what? A plus B is a singular matrix. That's it. This carries 15 marks. A plus B is a singular matrix, right? Very simple proof. So I'm finding determinant of A plus B whole square. If determinant of A plus B whole square is 0 means obviously determinant of A plus B has to be 0, right? Okay. We'll move on to fourth problem. Okay, so again very simple problem, standard problem. So they have given the matrix A. First you want to find the rank of A, and then you want to find the dimension for null space of A, right? Okay, so first we will find rank of A, and then also we will find the null space of A. So A is given as, so I'll just change the first two rows, 1 1 minus 8 1 5 7 2 1 2 3 5 0 3 4 minus 3 1. I hope everyone knows how to find rank. I'm not going to explain, I'm just going to do the problem. R2 is transformed to R2 minus 5 times R1. R3 is transformed to R3 minus 2 times R1. R4 is transformed to R4 minus 3 times R1. So this is equivalent to 1, 1 minus 8, 1. You multiply 4 and then you subtract. Sorry, you multiply 5 and then you subtract. You multiply 5 and then you subtract. You multiply 5 and then you subtract. So it will be 2 plus 40. So it will be 42. You multiply 5 and then you subtract. So 1 minus 5 is minus 4. You multiply 2 and then you subtract. 3 minus 2 is 1. You multiply 2, it will be minus 16. Minus 16. 5 plus 16, it will be 21. You multiply R3 minus 2 times R1. So it will be minus 2. Right? Now here you multiply 3 and then you subtract. You multiply 3 and then you subtract. You multiply 3 and then you subtract. So it will be minus 3 plus 24. You multiply 3 and then you subtract. Wow, reduces very easily, right? So R3 is transformed to 2 times R3 minus R2. R4 is transformed to 2 times R4 minus R2, right? So you can see third row and fourth row will be 0. So this reduces to 1, 1 minus 8, 1, 0, 2, 42 minus 4. We'll check this once again. So R2 is correct only. So 0 to 42 minus 4. This will become 0, 0, 0, 0, 0, 0, 0, 0. So this is in row echelon form. First row, first non-zero element. Below that everything is 0. Second row, first non-zero element. Below that everything is 0. Third row, fourth row, there is no non-zero element. So here there are two non-zero rows. Here there are two non-zero rows. So what is rank of A? Rank of A is 2. We done with the first part. Now we'll find the dimension of subspace. We need to find the dimension of subspace. You need to find all those x1, x2, x3, x4 such that A times x1, x2, x3, x4. See, you have to solve this homogeneous system. That's it. C equal to 0. So what is your A? A is 5, 7, 2, 1, 1, 1 minus 8, 1, 2, 3, 5, 0, 3, 4 minus 3, 1, x1, x2, x3, x4 is equal to 0. So we need to solve this homogeneous system of linear equation. That is, we are finding the null space here actually, right? So solve this homogeneous system of equation. See, this reduces to you find the augmented matrix A comma O, right? So this augmented matrix A comma O, so which is 5, 7, 2, 1, 1, 1 minus 8, 1, 2, 3, 5, 0, 3, 4 minus 3, 1, then we have 0, 0, 0, 0. Here we need to reduce this to row echelon form. I can write this directly because I know this matrix is equivalent to, after reducing, because we are reducing this matrix here also, right? After reducing to row echelon form, you will have 1, 1 minus 8, 1, 0, 2, 42 minus 4, 0, 0, 0, 0, 0, 0, 0, 0. Then we have 0, 0, 0, 0. Right? So here we see that rank of A is equal to 2. That means number of free variable is n minus rank of A. So n is 4, rank is 2. So we have two free variable. And what is the equation we have? What are the equations we have? X1 plus x2. What are the equations we have? X1 plus x2 minus 8x3 minus 8x3 plus x4 is equal to 0. Minus 8x3 plus x4 is equal to 0. And then second equation is 2x2 minus 42x3. 2x2 minus 42x3. 2x2 minus 42x3 minus 4x4 minus 4x4 is equal to 0, right? So already we have two free variables. Let us take x3 to be some k1, x4 to be k2, right? All this has 1, all this has 2. So from 2, we have x2 minus 21, x3 minus 2, x4 is equal to 0. So x2 is 21 times x3 plus 2 times x4. So 21 times x3 is k1, x4 is k2. So this is our x2 value. And what is our x1? So x1 is 8 times x3 minus x4 minus x2. So 8 times, what is x3? x3 is k1. What is x4? It is k2 minus x2. So minus 21 times k1 minus 2 times k2. So 8 minus 21, it is minus 13k1 minus 3k2. So therefore, our solution space x1, x2, x3, x4 is given by x1 is minus 13k1 minus 3k2, right? Minus 13k1 minus 3k2, and then just a minute. You correct, right? 21. What is x1 actually? What is x1? x1 x1 plus x2 minus 8x3 plus x4. x1 is 8x3 minus x2 minus x4. So x4 is k2, x2 is uh, x2 minus 2 divided by 2, x2 minus 21 x3, 8x3 minus x4 minus x2. So 8 times x3 is minus x4 minus 21 k1 minus 2 k2. So 8 minus 21. Okay, let us check this, right? What happens if I take k1, k2 both to be equal to 1? It will be minus 13 minus 3 will be minus 16. X2 will be 23. Then we have 1, 1. We see whether it satisfies or not. So x1 plus x2. So x1 plus x2. So minus 16 plus 23. Minus 16 plus 23 is 7. 7 plus 1, 8. Yes, correct only. Minus 13 k1 minus 3 k2. X2 is 21 k1 plus 2 k2, comma k1, comma k2. Right? So this is our solution space. And the solution space is spanned by, if I take k1 outside, minus 13, 21, 1, 0 plus k2 times minus 3, 2, 0, 1. So this is our basis for solution space, and you can see what is our nullity. Nullity is 2. What they are asking actually, find the dimension of subspace of A. So dimension is 2, right? So this is our null space of T. See, this is a null. What is a null space? We are collecting. We are finding all those x1, x2, x3, x4 that is mapping to 0. So that x1, x2, x3, x4 is spanned by these two vectors. So therefore nullity of T is 2. Right? Nullity of T is 2. This is correct only, right? Minus 16. If I put here, we'll have what? 22 into x2, 46. So 46 minus 46 is correct only. So this is the basis for null space of T. These two vector are, if I multiply any k1, k2, these two vector will be a basis. And nullity of T is 2. To find the rank of A, so rank of A is 2. Find the dimension of subspace. Actually, rank is 2 means nullity has to be 2 because rank plus nullity is equal to dimension of this, which is 4. And since here you are finding the, for this matrix we are finding null space of T actually. So actually the question is like, this is 15 marks, this is 5 mark. This is how they divided. For this 5 mark, you can also do like, this is nothing but your null space of T, because they're asking on nullity, right? They're not asking you to find the basis for null space of T. You can say like, this is our null space for this transformation, and we know for this transformation rank is 2. Rank plus nullity is equal to 4. That means nullity has to be equal to 2. You can also do like that, but for the safer zone, you just find the basis for null space of T, and you can say that dimension is 2. You can do like anything. Okay. um, what we are finding all those x1, x2, x3, x4 that satisfies 8 times this is 0. So that x1, x2, x3, x4 are given by this, right? So that means this is spanned by these two vectors. Okay, so we'll move on to the final problem of this current year, this 20 for this year paper 2019. State Cayley-Hamilton theorem, and using this theorem find a power 100, right? So we need to state Cayley-Hamilton theorem, and in this we have to find a power 100. So what is Cayley-Hamilton theorem? Every square matrix satisfies its own characteristic equation, right? Cayley-Hamilton theorem. Every square matrix, every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. So we will find characteristic equation for this 3 by 3 matrix, and then we will say that that characteristic equation, that matrix satisfies every square matrix satisfies its own characteristic equation. So we will prove this. So first what we'll do is, we will find the characteristic equation or characteristic polynomial for this matrix 1 0 0 1 0 1 0 1 0. So what is the characteristic equation for a 3 by 3 matrix? Lambda cube minus s1 lambda square plus s2 lambda minus s3. This is our characteristic polynomial for a 3 by 3 matrix. What is s1 here? S1 is the trace of A. What is the trace of A here? 1 plus 0 plus 0. Trace means sum of diagonal elements. S2 is nothing but the, for every diagonal, you need to find the minor. So what is the minor for 1? You omit the corresponding column, omit the corresponding row. 0 1 1 0 plus that is, you need to find the minus or diagonal elements. So for 1 the minor is 0 1 1 0, and for 0 the minor is 1 0 0 0, and for this diagonal the minor is 1 0 1 0. What is this? 0 minus 1, so it will be minus 1, right? This is 0, this is 0, this is minus 1, and S3 is nothing but determinant of A. What is determinant of 1 0 0 1 0 1 0 1 0? So it is nothing but 1 into 0 minus 1. So minus 1 is your determinant. So therefore, the characteristic polynomial is given by lambda cube minus s1 lambda square plus s2 lambda minus s3. This is your characteristic polynomial. We already found all those values. So lambda cube S1, S1 is 1, so minus lambda square, S2 is minus 1, so minus lambda minus S3, so plus 1. This is your characteristic equation, right? Okay. Now we need to show that every square matrix satisfies its own characteristic equation. That is, if you put lambda to be equal to k, a cube minus a square minus a plus I, we need to show it is equal to 0. It means this equation is satisfied by this matrix. Satisfied means if you substitute that, it will be equal to 0, right? Okay. Now we will find a cube minus a square minus a plus I. We will show it is equal to a 0 matrix. Okay. So first, what is a square? A square is 1 0 0 1 0 1 0 1 0 1 0 0 1 0 1 0 1 0. This will be what? 1 plus 0 plus 0. 1 into 0, 0 into 0, 0 into 0. 1 into 0, 0 into 1, 0 into 0. 1 into 1, 0 into 1. 1 into 0, 0 0, 1 into 1, 1 into 0, 0 into 1, 1 into 0, 0 1, 1 1, 0 0, 1 0, 0 1, 0 0, 1 1. This is your a square, right? Now similarly, you find a cube. So a square into a. So 1 0 0, 1 1 0, 1 0 1 times a. So a is 1 0 0, 1 0 1, 0 1 0. So 1 into 1, 0 into 1, 0 into 0, 1 into 0, 0 into 0, 0 into 1, 1 0, 0 1, 0 0, 1 into 1, 1 into 1 will be 2, 1 into 0, 1 into 0, 0 into 1, 1 into 0, 1 into 0, 0 into 1, then 1 0, 1 1, 1 1, 0 1, 1 into 0, 0 0, 1 0, 0 1, so on. So uh, this is your A cube matrix, right? This is your A cube matrix. Actually, they haven't state Cayley-Hamilton theorem, right? They haven't asked you to verify Cayley-Hamilton theorem. Actually, we don't need to verify here also. Because they are asking you to check state Cayley-Hamilton theorem. That's it. Okay, we'll verify, no problem. Suppose if they say verify means you need to show this equal to 0. If not, you can go to the proceed, you can proceed for next thing. Okay, so A cube. So A cube is 1 0 0, 2 0 1, 1 1 0 minus A square 1 0 0, 1 1 0, 1 0 1 minus A 1 0 0, 1 0 1, 0 1 0 plus I 1 0 0, 0 1 0, 0 0. To add this 1 minus 1 0 minus 1 plus 1 0, 0 0 0 0, 0 0 0 0. 2 minus 1 1, 1 minus 1 0, 1 plus 0 0, 0 minus 1 minus 1, minus 1 minus 0 plus 1 0, 1 minus 0 minus 1 plus 0, 1 minus 1 0, 1 minus 0 minus 1, 0 minus 1 minus 1, minus 1 minus 0 plus 1. So you can see that every square matrix satisfies its own characteristic equation. This is a zero matrix of order 3 cross 3. It satisfies zero means it is zero matrix. Okay. So state Cayley-Hamilton theorem. Actually, we have verified also. Using this, we need to find a power 100. So what is a actually? A is What is A? The matrix A is given by 1 0 0 1 0 0 1 0 1 1 0 1 0 1 0, right? Okay. So what we need to do is we need to find A power 100, right? So we need to find some pattern. We need to find some pattern in the powers, right? We need to find some pattern in the powers. Okay. So what we have, we know that every square matrix satisfies its own characteristic equation. So we have A cube is equal to A square plus A minus I. A square plus A minus I, right? A cube is A square plus A minus I. Okay. So call this as 1. So you multiply A throughout. You multiply A throughout. You multiply A throughout. You multiply A. So we have A power 4 is equal to A cube plus A square minus A. What is A cube? Again you substitute. A cube is A square plus A minus I plus A square minus A. So these two will get cancelled. So we have 2A square minus I. So A power 4 turns out to be 2A square minus I. So multiply A again. Multiply A again. So what is A power 5? A power 5 is 2A cube minus A. So 2 times what is A cube? A square plus A minus I minus A. So we have 2A square plus 2A minus 2I, or else we will find A power 6 directly, because 100 is an even number, right? So we'll try to find a pattern for some even numbers alone. We'll multiply A square. So A power 6 will be 2A power 4 minus A square. So 2 times what is A power 4? 2A square minus I minus 2A square. So 4A square minus 2I minus A square. So this, you are getting this to be 3A square minus 2I. This is A power 6 value. So again we will find A power 8. We will multiply A square again. What is A power 8? So A power 8 is given by you again multiply A square. So 3A power 4 minus 2A square. So 3 times what is A power 4 again? So A power 4 is 2A square minus I minus 2A square. So 6A square minus 2A square. 4A square minus 3I. This is the value of A power 8. Right? Okay. We'll find multiply A square again. We'll try to find some pattern. So A power 10 is 4A power 4 minus 3A square. Again, what is A power 4? 2A square minus I minus 3A square. So 8A square minus 3A square. 5A square. 8A square minus 3A square. 5A square minus 4I minus 4I. Is there any pattern here? Is there any pattern here? You can see, if this is n, this is what? N by 2, and this is n by 2 minus 1. That is a pattern, right? If this is n, this is n by 2, this is n by 2 minus 1. So if you continue like this, what will be my A power 100? So n by 2 is 50. So 50A square minus 49I will be my value of A power 100, right? 50 a square minus 49 will be my a power 100. So 50 times a square. What is a square? Already we have found a square. 100, 101, 100, 101, 110 minus 49i. 49 0 0 0 49 0 0 0 0 0 49. So this will be t minus 49 is 1. T minus 49 is 1 0 0. Then here we have 50. Then here we have minus 49. Then here also we have t. Then here we have t. Then we have minus 49 here. So 100 um, 10 what is a square? A square. Okay, okay. Actually, this is a square, right? I written this as a square. 100, 110, 100, 100. Sorry. A square is what? This is a square, right? I written this 100, 110, 101. 110, 110, 101. Right? Now you multiply this. So 50 minus 49. So 50 minus 49 is 1. And then 50 minus 0, 0 minus 0. And then here we have 50, right? And then here you have 50 minus 49. And then we have 0 minus 0. And then here we have 50. Then we have 0 minus 0. Then we have 50 minus 49, 1. So 100, 50, 10, 50, 01 is the value of a power 100, right? Okay, so that's it. So we are done with the fifth problem also. So it says Cayley-Hamilton theorem. Using that, we have to find the value of a power 100. So we have found some pattern in all the square terms, square powers, right? Okay. So that's it. All five problems are very easy. So in the next class, we will do 2018 paper. Right? So thank you. All the best.